On today's episode, will China beat the USA to commercial eVTOL services? Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. It may seem hard to believe, but from the early days of the helicopter, there were serious doubts about whether vertical flight would ever have a practical use. Bell Aircraft, one of the pioneers of commercial helicopters along with Vought Sikorsky, produced a promotional film that suggested the use of helicopters as personal air vehicles, taking you from your driveway to the shopping plaza in minutes. Of course, the pilot training and skill required to safely fly helicopters is significant, and only the most affluent use helicopters as personal transportation today. But that may be changing. Dozens of mobility companies, from garage startups to heavyweights like Boeing and Airbus, are racing to use advanced composite structures along with lightweight batteries and electric motors driving multiple lift rotors to create what are essentially gigantic versions of commercial drones. The goal is simple. Create a form of intracity transport that does from rooftops and parking lots what taxis do on the streets today. Now, obviously, not everyone can qualify as a helicopter pilot, and it's widely assumed that eVTOL transport will be autonomous, but like autonomous driving for road vehicles, it's more difficult than it looks. Many experts believe that the initial generation of flying taxis will be piloted, in the way that taxis are driven by cab drivers today, but with flight control systems that are highly redundant, highly automated, and will use a pilot training and licensing system that's tailored to these unique vehicles. Technically, it's easy to see why. Conventional helicopter flying using cyclic and collective control inputs is not only tricky, but it's technically challenging for the machine itself. In forward flight, the advancing rotor must have a lower angle of attack than the retreating rotor to account for the forward motion component of the air velocity over the blades. This requires a complex mechanism, and to complicate it even further, the rotor head itself must tilt to induce motion in the desired direction of travel, and the blades require another degree of freedom using bearings or a teetering hinge to allow this movement. Look at a helicopter rotor head and you can see the complexity in the multiple shafts, linkages, and bearings required. The eVTOL does away with this complexity by its very nature. Power is distributed amongst multiple electric motors, each spinning a smaller rotor with a far simpler fixed-pitch propeller. Counter-rotating power plants on each side of the vehicle eliminate the need for an anti-torque tail rotor, and with a fly-by-wire system operating with stability control, it should be possible to keep the vehicle stable by varying individual motor RPM automatically. This could simplify the pilot's workload, possibly allowing a licensing scheme that would make it cost-effective to operate air taxi services with a professional in the cockpit. And of course, the more advanced the stability control systems, the more likely that a private owner with minimal skills beyond those needed to drive a car will be able to operate one of these things. Eventually, of course, they will be fully autonomous. Right now, in China, 2 potential vehicles are in that country's Civil Aviation Administration certification process, the EHang EH216S and the Aerofugia AE200. The Chinese have several advantages in developing this technology. Risk tolerance is government determined in China, and once certified, their airframe makers and taxi operators will not face the daunting prospect of American tort law and liability insurance. For the Chinese government, it's an opportunity to lead the world in an important new transportation technology and potentially become a global center of excellence for electric air mobility. Without doubt, European and American authorities are watching with interest, as are the aircraft makers. Is there smart play to lead in this technology, or wait and see? We'll have to wait and see. Well, that's it for today's episode of End of the Line, brought to you by engineering.com. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. For our deeper engineering video series for the manufacturing professional, visit engineering.com TV to watch exclusive shows like Manufacturing the Future, not found here on our YouTube channel. The link is in the description below. Thanks for watching.